part, we have to talk about definite integrals. This is where I get the groans and the moans and the grosses and the yucks because, yes, this is where the unit circle is really, there it is going to rear its ugly head. So what I need to do, focus here, is this. We're going to do question 18 together, and then I'm going to let you do one question, number 19, and then we're going to move on to the third and final part of this lesson today. Hopefully we will finish early. We'll cut that out of the editing. Yes. Okay. So first thing I want to acknowledge is if you're doing a definite integral, ignore the integrals. Just go to sine of 2x, cosine 2x, sine of 2x. So we're going to make our u, again, because it's boring old sine and cosine, there's no powers here. We're going to make u equal to sine of 2x. And then we're going to make our derivative, because again, the derivative of sine is cosine of 2x times, thank you, times 2 dx. And we go over here and say, okay, I've got my, and again, you're going to get sick of me doing this, but I'm going to do it one more time. So I have my u, bless you, is written right here. There's my u. My du is this whole thing and this whole thing. So it's this and this without the 2. So I'm going to pull the 2 out. And I'm left with cosine 2x dx. So far so good? So don't forget about that. This is one of those things where on a multiple choice question on your exams, the 1/2, one of the answers won't have the 1/2. So let's do this. So we're going to have 1/2. We're going to integrate. Now what we do here is we're going to have a u and a du. So far so good? Now if you change your bounds, and this is going back to what we did before, if you change your bounds, and we're going to do that right now, and I'll do it in a different color for us. So when x is equal to pi over 4 and x is equal to 0, let's change our bounds. So remember, we're looking right here. This is our relationship between u and x. When x is 0, what is the sign of 0? 0. Okay, so there's our 0. I'm changing the color for us here. And then when x is pi over 4, so be careful. So it's sine of 2 times pi over 4, because a lot of times, I know we're not a big fan of these unit circles, but they actually write these questions to give you pretty much quadrantals, and quadrant 1 is really where we hit. What's the sine of pi over 2? 1. Now let me just say again, and we talked about this last week, I believe. This is your new problem. You solve this, you solve the problem itself. So you don't have to worry about unit circles, you don't have to plug back in for cosine or sine. This is your problem. So I'm going to get rid of this. And we're going to do this exactly as you see it. So you're basically, this is your new question. How easy is that?
So easy.
Yeah, thank you. It's so easy, right? That's it. That's all you do. So hopefully it's easy. Let's do it. So 1/2, we're going to integrate u as u squared over 2 from 0 to 1. And I just want to remind you what I suggest doing. Eventually it's going to come, maybe. What I suggest doing is going ahead and pulling out the 1/2 again. Right? Go ahead and pull out the numbers. Why would you want to plug in stuff that then you have to divide by 2? You can always pull out constants. And so we're going to do this. We're going to plug in 1, we get 1 squared. We plug in 0, we get 0 squared. This answer is going to be 1/4. The answer is 1/4. Do we remember how to use our graphing calculators to check this answer? Math 9, so we'll talk about that in a second. But let's look back at this one for a second, because I want you to try this one. This one, I don't care about this one right now. But this one, it's 0 to pi over 2. But we found what our u was. Derivative, check to make sure our constant wasn't in our integral. It's not. So we pull it out. We rewrote our u du. We changed our bounds. And once we do that, this is where we stop. Then we look, well, not really where we stop, but where we kind of did say, new problem, integrate this, here's our answer. Can you please, for me, try question 19 while I show you the calculator part, and we're going to go to our last and final part, where we should finish up early today, yes. Oh, try 19 and then use your graphing calculator to see if you got it right. See if you can plug this sucker in, because it's kind of crazy. Math 9, 0. Ooh. Sine. Plug in there. Now quit. 0 to pi over 4, making sure you're in radian. And now we're going to go over to alpha trace y1 dx, and then we press enter, and we're going to get 1/4. Those are our answer. So now we're going to plug this one in. We're going to plug in number 19. Y equals, let's go to y2. Cosine of t. How do you do that? Cosine of x, close in both your brackets, raised to the third, times sine of x. There's your function. We're using y2 now. We're going to quit. Math 9 from 0 to pi divided by 2. Oops, sorry about that. Pi divided by 2. Let's get rid of that. Y2, so alpha trace dx, and we get 1/4 again.